Hello students, in this class we shall discuss power in RLC circuit. We have already discussed the response current when an EMF epsilon, that is V naught sin omega t, is applied to one RLC circuit. So what is the power? Okay, power means initially instantaneous power. From that we shall find out the average power. First of all, instantaneous power is nothing but instantaneous voltage into instantaneous current. Here instantaneous voltage is epsilon and instantaneous current is I. This is equal to, in place of epsilon, I is this much, then I can write it as V naught I naught I'll divide 2 and multiply 2 also, then sin omega t into sin of omega t plus phi. Now this is equal to two sin A sin B. Formula is cos A minus B minus cos A plus B. Cos A is omega t minus B is omega t plus phi, so omega t minus phi, then cos A plus B into, sorry, not into, it is minus cos A plus B. It will be minus cos A is omega t plus B is omega t plus phi. Now omega t gets cancelled. Cos of minus phi, that is cos phi, then minus cos 2 omega t plus phi. Okay, now this is the instantaneous power, but we are interested in average power. This implies average power is equal to, average means mean of this pi, that is average of this quantity. Then first term is our V naught I naught by 2 cos phi, V naught I naught by 2 into cos phi. Here you look, everything is constant here, that means its average value is also this much. Then minus second term is V naught I naught by 2 cos of this much. Now look, this is a cosine function, here is t term, that means this is a cosine function of time period or time, that means its average value over one cycle will be 0. So I will not find it out, I will directly write here 0. Then that means average power has become V naught I naught cos phi by 2. We do know that V RMS is equal to V naught by root 2. Similarly, I RMS is equal to I naught by root 2. Implies P average is equal to V naught by root 2 into I naught by root 2 into cos phi. Implies P average is equal to V RMS into I RMS into cos phi. In place of V RMS I can simply write V also. then I, then cos phi. Okay, normally in AC RMS value is written directly, okay, directly V and I. So this is the final formula of average power. Now from this we can get some cases. Okay, now we shall emphasize something more on this term. Okay, so first of all, what is cos phi here? What is cos phi here? Okay, cos phi is called power factor. Power factor. Then accordingly there will be different cases because phi has different values. First of all, this is case 1. Case 1. Let phi, case 1 is phi is equal to 0. That means there is the phase difference between voltage and current is 0. They are in phase. What does it mean? It means voltage and currents are in phase, or it is called resonance condition. Phi is equal to 0 means resonance condition. Okay. Now what is cos phi value? Is equal to 1. That means power factor of a resonant circuit is equal to 1. Okay. This is number 1 condition. Case number 1. Anything else left here? Resonance, then cos phi, then anything else? Nothing else. Then case number 2. So what power becomes now? Yes. What power? P average is equal to simply V into I. Okay. This is case number 1. Now come to next case. Case number 2. Let phi be pi by 2. If phi becomes pi by 2, this implies tan phi. We do know tan phi is equal to, recall from the triangle rule, that if this is a right angle triangle, this is phi, this is R, this is XL minus XC mod, this is Z. Now tan phi is obviously this by this, it will be XL minus XC mod by R. Phi is 90 degree, this is equal to tan 90 is nothing but infinity. Implies, what is infinity value? XL minus XC mod by R is equal to, I can write infinity as 1 by 0. If you cross multiply, then R is equal to 0. This is result of case number 2. If R is 0, in the circuit R does not exist. That means it exists but it does not serve any purpose. Then what does it mean? It means if R becomes 0, then XL minus XC is having some value. This quantity is having some value, it is already present, but R becomes 0. That means in the circuit only inductor is there and capacitor is there. Okay, that means the circuit will become like inductor and capacitor. Okay, now come to the average power. What is average power of this circuit? P average is equal to cos phi, so Vi cos pi by 2, this is equal to 0. Now this is obvious case because inductor is reactive element, capacitor is also reactive element, and we do know that both inductor and capacitor do not consume any power. They are always energy storing elements. Okay, that's why power is 0 because real power consuming element resistor is absent here. Now now one thing, current is flowing but no power is consumed here. Then this current, of course we do know that if current flows, that means there should be some energy consumption, but here current is flowing but power is not consumed. That means this current is called wattless current. In this case, this current I is called wattless current. Why wattless? Watt is the unit of power. Since no power consumption is there, so this is called wattless current. So the current flowing in the circuit when there are only reactive elements, no resistive element, then the current is called wattless current. Okay. Reactive elements means only inductor and capacitor. Now this is all about your this is case 1, case 2. Now come to the third case, that is the usual case. Okay. What is that usual case? The formula itself. Case 3. Case 3 is if phi is between 0 and pi by 2, then the formula P average is Vi cos phi, and we do know this formula already. That means this formula is applicable only if phi is between 0 and pi by 2. If it is 0, case 1 comes, that means power is maximum power consumption, because cos phi is 1. Then at pi by 2, 0 power, no power is consumed. That is, the current is called wattless current. Okay. Now this is all about your power consumption in RLC circuit. Okay. Thank you.